So in the previous class, we already see that about the supervised learning. So the type of the problems that we need to use the supervised learning is mostly for classification and regression. So in this class, we try to see in detail about what is classification and what is regression, and we can just see by using some detailed examples. So we can start from the classification parts. So just this one is a highlight that's from the previous classes about the type of the machine learning algorithm. So no need to just repeat again. So here just the basic in order to highlight that this supervised learning is for classification and regression. So now the first one is just let's start from the classification part, and we can see that the detail. So let's start what is classification. So when you say that classification, the aim is to predict the categorical classes labels for new tuples or samples. So the input is a training set of tuple or samples, each with a class label. Because classification is a type of supervised learning, a training of each tuples or samples or features with corresponding with a class labels. So that means each x value is corresponding into the y value. That's called the class labels. The output is defined the model or a classifier based on the training set and the class label. That means our model, just we say that, for example, we have x and y. This one is given into the model, and then the final one is y. See, x and y value input into the model, and then finally our output value is indicating that the y or the classifier. So that is called the model or classifier based on training set and the class label, because the training set is based on this one. Finally, just when we give this x value, try to predict the output value. That is the way, just what is called the classifiers. Classification models are used for problems where the output variable can be categorized. So when we say that classification, mostly the output value can be categorized. Let's say maybe like yes or no. So the output result is maybe either yes or no, which is categorical. So the output is maybe just either yes or no, or maybe just type of pass or fail. When you give some data, the output is expected either pass or fail. That is why we say that categorical. So classification models are used to predict or classify the category of the data, just two categories. This one is, for example, it showed that the medical data, that in order to classify that, based on the tumor size, just classify the type of the tumor, like malignant or benign. So here the tumor size and also the age. So the data includes this data. For example, let's say, like this one. So just for example, x value and then y value. In the x value is represent. The x value is represent. This x value is have like tumor size and the age. So x we can just categorize into we can define this one is just x1 and the x1 and x2 here. Just we can just classify by x1 and x2 here, and there is y value here. X1 and x2 represent the age and the tumor size, and the y is like represent the expected output. So the data, for example, is includes the tumor size and the age. So based on the tumor size and the age, the data is classified as these two classes. So this is also categorical. The class is maybe either benign or malignant. So this represent, the red one is represent, for example, the tumor type is like this one, that is benign, or this one is the blue like is like categorized as malignant. So there is also, for example, here the red one is, it showed that the class which is falsely classified in the malignant group, but the exact or the real one is the benign, but it's just type of falsely classified into the other classes. That is called the error. In this case also, there is some data that is falsely classified into the benign, but the reality is should be in this one. That is called the error. So actually, that is called when we just check the performance. The performance measure showed that, for example, let's say 95%. That means 5% is indicating that there is some error that is wrongly classified into the data. So we can just, when you say that classification, this is just in order to predict or classify the categorical of the data. So in general, in classification, given a collection of records, which is a training set, each record contains set of attributes. Attribute means like tuples or samples, and also each record also has a discrete class labels, that is y. So attribute is x and class label is y, so the correspondent of x and y. Learn a model that predicts the class label as a function of the value of the attributes. So the goal is the model should design class labels to previously unseen record as accuracy as possible. Then finally, in order to test the model, we can use the test sets used to determine the accuracy of the model. So this is the way how just similar. Actually, this is the previous one. In classification, just we can give this one and then classify the car. That is we already seen this one. So in classification, in general, it is called a type of not only actually classification, also regression, or in general in supervised learning is we can say that a two-step process. A two-step process. The first one is the model construction. Model construction. So when you say that model construction, build the model from the training set. Starting from the training set, we can build the model. Each tuple and sample is assumed to belong to a predefined class as determined by the class level. So the first step is for model construction. The first one is just build the model from a training set. So just let's say we have a data set or a training set. That training set is just have tuples, sample or features, and also predefined classes. The training set of a tuple and a sample is used for a model construction, because always when we just build a model, the first thing is we should have the training data set, because without a training data set, we cannot build a model. The model is represented as a classification rule, a decision tree, or a mathematical formula. So in order to decide, or like the model is just for a prediction or classification, it can be just represent either maybe like classification rules, or based on decision trees, or by using for mathematical formulas, just try to classify and predict that data. So this is the first step, model construction. The second step is the model usage. So once the model is constructed and built, the second step is just using that model for classifying a future or unknown data. Once the model is trained and is ready to predict a new data or unseen data, unknown data, then the next step is just we can apply or implement that model in order to use for the real environments. So estimate then once we use to classify future or unknown data, the next one just estimate the accuracy of the model, because maybe always the model is may not be it's just perfect or good. Sometimes maybe the model is not good or may have huge errors. So in order to just adjust that one, we should be evaluate the performance. So accuracy is the one of the performance measurement metrics in order to determine whether our model is good or not. So if the performance is good, or if the accuracy is good, then we can just continue to use that model. Either if the performance or the accuracy is not good, we try to just tune different parameters in order to improve the performance. That is the way. So the known level of test sample is compared with the classified results from the model. Yeah, just in order to compare the performance, there is the ground truth, and then we can say that y is the ground truth, and then there is the output of the model. We can say that, for example, x, then there is the y in the x, and y. This is just, so y is like, y is the ground truth. The ground truth. And there is the prediction that is predict or estimated by the model. We can say that y1. So we can compare this y1 with y. If y1 and y is more similar, that means the model is predict or done accurately or classify accurately. Either if there is huge difference between this one, y and y1, that means the model is not accurately classify or predict, so we need to train again the model. This is the two-step process. So we need to see that actually in detail about how the models can be constructed from the initial one. So if the accuracy is acceptable, use the model to classify the data tuples whose class labels are not known. So if the accuracy for that one is good, that means in the next time we can classify the data that is not included in the training data, which is called the unseen data or unknown data. So this is the procedure that can be used in the model construction and the model usage. I think it's better to see that the basic procedures how to construct the models, the model construction, because this model construction also the huge steps that we need to consider different things. So because of that one, we need to see in detail about how to construct the model. So the basic steps in the model construction, the first step in model construction is the data collection part, because always the first step that we need to have is data. So the first step, data collection, that means gathering relevant data that contain feature and attributes and label classification from training the classification model. For example, this one it showed that there is a mobile ID, mobile package, download speed, and data limit usage. This just, for example, our data. Let's say, for example, we already collect this data. So we have this data. That means mobile ID, mobile package, and download speed is like input features, tuple or attributes, and let just data limit usage is like a class. We can say like this one. The second step is data pre-processing. Data pre-processing also one of the most important part in the model construction or in machine learning. So we should be clean and prepare the data, which is like more idea for the machine learning algorithm. So based on the way how the model or the algorithm can accept that data, we should be clean and prepare or make it ready for that data input into the algorithm. So the first one, for example, in data pre-processing, maybe the one thing that we should be consider is data cleaning. In data cleaning, pre-process data in order to reduce noises and handle missing values. For example, in this case, when you see this one, there is some missing data. For example, here the mobile package actually is fast plus, but the download speed is not filled. So that means this data is not important because the value is not, all the information is not fully assigned for this one. So because of this one, this is not important. So for that case, in order to just avoid like a misunderstanding, we need to remove this data because the information is not complete. That's called data cleaning. In this case also, this one is not assigned and not assigned, but just the data limit usage is already assigned, but so this information is not full. That means this machine cannot understand this one completely, so that this one maybe makes the machine misleading information. So because of this one, it's better to clean this one. And also here, there is a missing value, so we need to delete this one. So finally, our data, it looks like this one. This is called the one procedure that we say that data cleaning. So the first thing, the first step, we should be make the data which is clean and pre-processed. The other procedure in data pre-processing is relevance analysis or feature selection. Feature selection or relevance analysis means just only identify the most important feature that is used to determine the classification and a prediction. Sometimes some attributes may be not important. So just that attribute may be also mislead the model for the prediction or for decision. So That is mostly important to just select only relevant and redundant attributes also. So we can remove redundant attributes, relevant attributes, not important attributes can be removed. Maybe, for example, let's say that just an example. In this case, maybe mobile ID is maybe not more important for the decision. So if this attribute is not important, we can remove this one, or we can delete this one, and only mobile package, download speed, and then data limit usage may be more important. That's the one case. So especially if the attribute is too much, just using all of the attributes is maybe not important. So just only pick some attributes that is more have more effect on the decision. That is the way. The one step is that we should be do in the data pre-processing step. And then the other procedure in data pre-processing, data transformation. Actually, this one is just generalize or normalize the data. So data transformation is just this one is done in the coding part actually, because there is data normalization, that is a mid-max normalization, for example, just changing the data on the way the machine can understand that. So mostly because the machine can understand the value into 0 and 1. So if our digit is like, for example, based on fraction or like in the normal integer values, then in the data transformation part, in the coding part, the data is just changing into either 0 and 1 format, because mostly the computer is understand on that 0 and 1. So this one is the data transformation part is just done in the coding part, actually not in the CSV. But maybe the other one, data cleaning and just this data labeling, this one is just maybe before coding, we can also adjust in the Excel or CSV formats, and this part is we can be done on the coding part. So when you say that the other step, feature selection and extraction. Feature selection and extraction, identify and select the most relevant features that will contribute to the classification task. For example, this is like just some of the attributes. There is a user, about the item, about the context. So gender, age, genres, year, time, website. So year, time, and website is not important for our decision. So because of this one, we can remove this type of attributes, and then only, okay, I think time is important, just for only year, and the website is just related. And gender, age, genres, and time is selected for only for the training. So I think no need to maybe use all the attributes for the training. So just only select some important attributes, most relevant features, which is contribute to the classification task. This step aims to reduce dimensionality and improve the efficiency and effectiveness of the classification model. Actually, for this task, there is different algorithms for feature selection, like LDA or PCA. So this type of dimensionality reduction algorithms also, the main function is just only pick the most important attributes for the classification. So in order to determine these important attributes, actually there are different algorithms to do or to select the most important attributes just by comparing from that one, like LDA or PCA. So you can use this type of algorithms in order to decide which attribute is the most important. Then once we do this step, the next step is model selection. If our data is ready, then the next step is choosing an appropriate classification algorithm or a model based on the nature of the problem, the characteristics of the data, and the desired outcomes. So because from the classification algorithm, there are different type of classification algorithm, like for example, Kenyan or K-nearest neighbor, like support vector machine, decision tree, random forest, and the others. There are different algorithms, so we can choose one type of algorithm that is based on maybe the problem, characteristics of the data, or desired outcome, or maybe the efficiency actually, or the performance. So there are different common classification algorithms like decision tree, logistic regression, support vector machine, K-nearest neighbor, and neural network, and the others. So from this one, we can select just one algorithm. Once we select the model, the next step is train the model. So using the prepared data to train the selected classification models. So we already just, let's say that pick one algorithm, let's say support vector machine, and then using the already the pre-processed data, try to train the model using that data. So during this step, the model learns patterns and relationship between the features and the labels. That means the model, the select model understands how the relationship between the data or the map between the data X and Y, and understand that one. For example, this is the data. So this is the training data. The training data have like name, rank, years, and then the tenor. Tenor is a class. So if just name and rank, assistant professor, and year of experience is 3, so that whether this professor is tenor or no, you say that no. And also information, the year of experience is 5, and assistant professor, and year of experience is 5. That means it can become a tenor, so the class is tenor. If he is professor and the year of experience is 2, he become a tenor. Assistant professor, year of experience 6, it can be tenor is become yes. So from this one, have a classification algorithm and the model. That means the model can be designed based on this one is type of rule based. That means if rank is a professor, or if a year of experience is greater than or equal to 5 based on this data, that means he become a tenor is yes. So it's like the classifier or the model is designed or based on this one, his type of rule based type of the classifier model is designed or just decide based on the rules. If the rank of the professor is like professor is totally, if the rank is professor, is by default is tenor. Either if the rank is assistant professor, but if he had an experience more than 5, still he become a tenor. So based on this one, when we give new data, he can understand to classify the data. This is the way how to classify this one. So this is just the training one. We train this one, and then next time just testing that data. Then we train the model, and the next step is model evaluation. Assessing the performance of the trained model using evaluation metrics such as accuracy, precision, recall, F1 score, and confusion matrix. All this one is a type of evaluation metrics in the classification algorithms. So we can use this type of parameters. Maybe we can use one or all type of evaluation metrics, and we can see that the performance of the model. This step helps us to determine how well the model generalized to unseen data in order to just to determine that whether it meets the desired criteria for classification accuracy. After model evaluation, we can just see that if the performance is not good, we can make it hyperparameter tuning, fine-tuning the parameter of the classification algorithm to optimize its performance. So this process involves adjusting parameters such as learning rate, regularization strength, kernel type, 3D phase, or any other parameters, like maybe we can change it like either epoch, hidden layers, activation function. Just these parameters can be changed in order to improve the performance. So after evaluating the model, then the next step is depends on the model performance. If the evaluation performance is not good, so we can just adjust different parameters and then try to improve the performance. If the performance is good, the next step is just model deployment. We can deploy that model. So deploying the training classification model into production environment. Just we can implement this model into the real environment where it can be used to make predictions or new and unseen data. So after this one, just we try to just collect some data, a new data that is not included in training data, and we give this data to the train model, and the model try to predict their output values. That's called the model development. So this, for example, from the previous data, using the model in the prediction, just like testing data. So in the previous one, we have just training data, for example, here. So we train the model. So once in order to deploy the model, we can give a new test data here. So this one is, for example, already have a test data, and we have a unseen data here. This unseen data, the name is Jeff. He's a professor, and the year of experience is 4. So when you give this data for a classifier, the tenor classes become yes, because the rule it said that if the professor or rank is a professor, and if the year of the experience is greater than 5, he become a tenor. So this data, it showed that from the training data, it understands that because his rank is a professor, the model try to classify this as a tenor and become the class of yes. This is the way to implement the model in the real environments. You see, if rank is professor or year is greater than or equal to 5, that means it become the tenor. That is the classification. So this is a classification. When you come in the classification, actually there are 2 types of classification. Like it depends on the data. That means binary and multi-class classification. Binary classification means the classification problem only has 2 classes. That's called binary classification. Let's say, for example, this one is an example of a binary classification. So the class is only 2, either this one or this one. That is called binary classification. So in our data nature, if the class is either 0 or 1, or either yes or no, that means which is called, we can say that a binary classification. This is the way how to implement that one. Example, benign or malignant tumor, or spam or no spam email, classifying credit card transaction as legitimate or fraudulent. This one is just type of binary classification because the class is only 2, just the category is only 2. That is called binary classification. If the number of the class is more than 2 or 3 or more classes, it's referred to as multi-class classification. For example, categorize news or stories as, let's say, for example, we have the data, a news data, or just a newspaper. So from the newspaper, we can categorize like the story of that newspaper. Is that the story is related to finance? Is that story related to weather, sport, etc.? That means the class is more than 3. 3 and finance, weather, entertainment, and sport. So if the class is 3 and more, we can say that multi-class classification. Let's say this one. This diagram shows that have one class here, another class here, and this one is 3 class. So it's just categorized into different classes, which is called the multi-class classification. When you design your data or when you collect your data, just like that, for example, your data is, if only have a 2 class, you can say that just binary classification, or either if the data nature is like, or if the class is also possible to have more than 2 classes. So the category is more than 2 classes, that is, we can say that multi-class classification. An example in the spam filtering, there is training data, the spam filter, like for example here, there is a spam and then the function. So that's based on this one, just the category is spam yes or no. So this red one is show that spam, and the other one is from the email it say that no, the class is yes or no, which is called a binary classification examples. So when new email is here, and the class is either yes or no, that's when we say that binary classification. This is the same case actually in the incoming one. The training data, for example, is just like a combination of the red one is a spam and the green one is a normal one. So finally classifies the spam one is classified to this one, the normal one or the inbox one is classified to this one. This is called spam filter. In the multi-class classification, you see this one is a newspaper here from different sources, and then we can give for the model, and the classes become, this newspaper is more related to politics, either if finance, sport, economy, and the other things. So the training data is like this one, different documents. So this data can be classified like into multi-classes. So for this case, this document is training data, as then is already trained, the model is trained, and finally we can get a classification for politics, finance, and sport. So this one is sport data, and finance news, politic news. So because of training for this one, the final result like this one. Also this one, for example, different animals with the classes elephant, a tiger, a cat. That means we have 3 class or category. Then we can give for a classifier, and then when you give this animal, it say that from this 3 class for the categorization, which is the same one. Another example is like character recognition. An input is X and the output is Y, because this type of classification is type of supervised learning, so we need to define both the input and the output. So this is the character that we need to recognize by using the model. It is a multi-class classification. Do you think that this one is a multi-classification, and why? The reason. I think we try to just try why we say that, whether it is a multi-class classification or just binary classification. For this case, we can say that this one is, yes, it's a multi-class classification, because just this one is a character. Maybe in this one is, he said that C, but the model maybe also can try to just suggest other characters, because there is a number of characters. So maybe the recognition, maybe this one he understand like L, or maybe also other characters maybe for this one like U. So maybe the result is maybe L, maybe C, maybe U, or any other character. So because of that one, is not only specific to this one. C is maybe the accuracy, but the model also predict the other characters, because there is too much characters. So because of that one, the expected output may be like other characters also. We can say that is a multi-class classification. But actually in this case, just the model understand that one, this one, and it's not clear whether this one is C or the other character, maybe L also. So but the model is say that this one is C. But in case there is other options, maybe also try to just recognize as another character. Because of that one, we can say that a multi-class classification. That's why it's called multi-class. The other concept in the classification part, both in the binary and multi-class classification, there is a way of linear and non-linear ways. So depends on our data nature, the data or the classification may be either linear or non-linearly separated. As shown in the figure, linear and non-linearly separated data for binary classification problems. This one is, for example, for binary one. So in this case is linear. That means between in order to separate the two classes, just only using linear lines. That means the data is easy to separate just by using linear lines. And this case is a non-linear, because it's not a straight line, but in order to separate the two classes, just using different lines. That is, the line is not a straight one. And also this one is also like the more complex non-linear. So when it becomes non-linear, actually it's difficult to separate or identify the class which is more complex. So depends on the data nature also, we should be consider that which algorithm is more important for linear and non-linear data. So we should be also consider that one, because non-linear one is more complex than the linear one, because in order to separate the data for each lines which is mixed with the other one, so it needs to just perfect lines in order to separate the non-linear data. This non-linearity, because some algorithms is only for linear one, and some algorithms only, just for non-linear and linear also. So we should be consider also our data natures based on linear or non-linear. We can just pick the perfect algorithm that fits for our data natures. This classification, like for example, some of the applications that we use for classification algorithms is like for pattern recognition or character recognition, face recognition. From the face we can recognize the pose, lighting, or the glass, the beard, makeup, hairstyle. We can recognize on that one. Character recognition, different handwriting styles, because every people have different writing styles. So we can give a different people's writing style or handwriting characters, and then we can just try to the machine can try to understand or detect that one. The speech recognition also, just the machine try to understand the speech or the voice from different peoples, and medical diagnosis from the symptom to illnesses. We can give the symptoms information for the model, and then the model try to predict the type of the disease for that one. This is just some of the application for the classification. But so as a discussion based on the previous information about classification, try to identify the following tasks are as a classification or not. Let's say, for example, email spam filtering, optical character recognition on scanners, recognize faces in pictures, predicting next week temperature, recognizing tumors in medical images, cluster similar data together, speech recognition on phones. So students try to classify this one, which one is classification or which application is for classification and which one is not based on this information. So I hope that you try to just consider that one from the previous information, try to identify which problem is for classification and which one is for the regression parts. From this one, some of is maybe like is not a classification part, that is for based on the discussions. So when you take this one, actually, for example, when you try to take the first one in the email spam filtering, just we say that email spam filtering is a type of classification algorithm because we say that spam just filtering or classification whether it's spam or not. So it's clearly it's type of classification. So we can say that the first one is it's said that yes, which is a classification task. Optical character recognition on the scanners also is like classification. Recognize face in the picture, which is a classification. Predict next week temperature. A prediction is not a classification, which is this one is a regression part. So this predicting next week temperature is not a classification task. The other one, cluster similar data together. Clustering is unsupervised learning, so which is not a classification part. So cluster similar data together is not a classification part. Rather, it is the clustering which is unsupervised learning. So number 6 also is not part of the classification. So these some of the examples that is a classification. In class we predict label Y or class for input X. So for example, in OCR, optical character recognition, as an input we can use images of different characters and the class the character. So when we give, for example, when some characters like that, maybe this character, this is an image of the character, and then the class is maybe by understanding this one, maybe the model is say that this character is C or L or any other one, and maybe like this one, maybe it's like more similar is that U or C, it depends. So the input is like this type of images, and then the class is the character. So we can give different characters, and then the model is displaying that one. In medical diagnosis, for example, predicting tumor cells as benign or malignant. So the input is the symptom, maybe the age of the patient, the gender of the patient, the past medical history. Using this type of information, then the model is try to classify the disease as benign or malignant. So just using, we can give some information as an input. So our data is like including symptoms, age, gender, and this information, and finally we can classify based on this information the disease types. We can classify the disease types by using the model. So the data nature arranged. In credit scoring, maybe the income, saving, profession, age, past financial history. Using this type of information, we can just in credit scoring with just the classes maybe accept and refuse, and then we can categorize like this one. Automatic essay grader means actually we can just collect the assignment from the students, and then in order to evaluate that document or assignment, just there is we can develop automatic essay graders. So as an input, we can give the document of the or the assignment of the student, and then the class, just by considering different contents on the assignment, it assigns different grades for that documents. So maybe there is student 1 class, student 1 document, student 2 document, student 3 document, student 4 document, maybe like 14, 15, 16, and then assign the grade for each document. This is also an example. So just always there is X function, finally there is a class label. This is the way. Another classification example is fraud detection. Classifying credit card transactions are legitimate or fraudulent. So the input is the account activity, general or maybe other information, and then the class is maybe either fraud or no fraud. So when we prepare the data, actually here, the table, maybe just we can prepare some data. I'm sorry. So the classes, our classes may be fraudulent or just no fraud. No fraud. So the attribute is maybe actually we can give different attributes on here. Different the activities, or we can write this one, and then the class is either fraudulent or no fraudulent here. So by assigning this one, just we can give this one, and finally we can get this type of activities. In face recognition also we can use different classification algorithms in order to identify the face, like this one. For example here, face recognition, this female, and also the age is here. So the labeling is the face, and then by labeling the face, just we can identify that whether male or female, and also we can determine the age of this one. So in input, as an input, image of the face, just this one, the image of the face is we can give for the algorithm, or the data is prepared like this one, and an output is just determine the person whether is male or female, like that one. So this one is image based data, so the image is labeling like just we should be labeled the face, and we put the data, and finally the output value is determined whether it's like male or female in this one. Categorize news stories as finance, weather, entertainment, sport. This one also, like in natural language processing, we can determine that because in news or categorizing the news stories is maybe it depends. So maybe if someone is just really focused on like entertainment, maybe in order to just pick entertainment documents, we can classify that document into different categories, and the person try to more focus on the interesting parts. So this is just recently, like classification is everywhere in the data science also. We can widely use this classification tasks in different tasks or in different fields. So this is also an example in spam filtering, for example, in order to categorize as normal or spam filter, just like that one. So it showed that one, which one is a normal one. So based on the email, actually, we can read just the email, and we can identify that which one is spam and which one is normal one. In digit recognition also, this one is an input, the images, the digits, and then image or pixels, like this one, and the output is like 0, 1, 2, 3, like that one. And if we need to determine that one, we can use that one. So the classification, we can give this one as an input or as training data, and this one is as an output data. So this is digit recognition, the one example. In object recognition also, for classification, this one is handwriting recognition. Maybe this one is difficult to understand by humans, but the machine can really understand the object recognition for these handwriting recognitions. So when you give this one as an image or as an input, and then the structured output is displayed by the machine, which is called brace. And the other application of classification is in 3D object recognition. For example, this one is satellite image. So from this satellite image, we can just classify or identify which one is a building and which one is a tree. So from these pictures, by just emphasis that the red line is indicated the buildings, and the green one is indicates the tree. So for object recognition also, we can use like a classification algorithm for this one. And credit scoring also. So in credit scoring, we have two classes, high risk and low risk. So we have an income and saving. So the information is the income and the saving of the person. So based on the income and saving informations, we can classify that this person is in the high risk and this person is low risk based on credit scoring. So if income greater than theta 1 and saving greater than theta 2, then low risk, else high risk. That means, you see, if the income is greater than theta 1 means x1, the x or the income is this one, theta 1, and the saving is represented by theta 2. So if income is greater than theta 1 and saving greater than theta 2, that means this leveling, this we can represent that below this one and below this one. That means this one is low risk, but this one is just categorized as high risk based on this data type in credit scoring. If when we use this type of examples, the other issue that should be we should be considered is evaluating the classification models. So when we use different classification algorithms, we should be evaluate the performance. So the evaluation metrics that we need to use is like accuracy, maybe speed, maybe robustness, scalability, and other measures is like different measurement techniques that evaluate or in order to compare and contrast different algorithms. Maybe, for example, we can use 3 or 4 different type of algorithms, and we can compare and contrast the performance in order to select the best one. So in order to select the best algorithms, we need to consider maybe the accuracy, like the classifier accuracy, or the speed, time to construct the model, that is the training time, or the time to use the model, which is a classification and a prediction time. So the speed also the one measurement techniques in order to classify or in order to compare the model. So the one is the time to construct the model, which is the training time, and the other one is the time to use the model, which is the testing time. That means after develop the model, we need to test unseen data. So the time takes to measure unseen data or new test data is called testing time or prediction time. Another evaluation technique or parameter is the roughness, handling noise and missing value. So which algorithm is highly handling the noise and missing values. So even if have just like maybe we have a noise data, so even if we have a noise data, which algorithm is try to predict or classify the algorithms accurately. So depends on that one. If still the algorithm can handle noises and missing values, that means this model is better. Scalability, efficiency on large database. Some algorithm is not good on large data set, and some algorithm is maybe is good in just large data sets. So depends on our data sets. If our data set is maybe is large, maybe we need to select the algorithm that is more fit for large data sets. If our data nature is too small, that means we need to select a simple algorithm that handles small data sets. So when we evaluate the classification methods, we need to consider like this type of thing. Interpretability, understanding insights provided by the model, just like the model, the complexity that understands the features and the patterns. That is also the one ways that represent the model. And other measures like goodness of rules such as decision tree size, compactness of classification rules, and the others are the parameter for evaluating the classifications. So this is the basic issue that is more concerned on the issues that's focused on the classification algorithms. I think about the evaluation techniques, we need to go in further in the next classes. So for today, I think this one is enough. We try to just see about, in order to summarize, like we see different type of, or what is supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. We try to highlight this one, and also we try to mention about like the difference between each type of algorithms, and like supervised learning is more important for classification and regression, and we see in detail about what is classification and what are the steps for the model construction, like starting from the data collection, data pre-processing, and then feature selection, and the model training, and finally evaluations. So this is the procedures, and we already highlight that one. I think in the next class we can go in detail about the evaluation techniques, what are the different evaluation metrics, and then we can revise the regression part and the application of this classification and regressions specifically in the optical communication and optical networks. So this is all about for today's class. Thank you very much for your attention.